Okay, let me share my screen. So if you can see my screen, say yes in the chat. If you cannot, say no. All right. Yes. All right, very good. Okay. So let's start. Today will be our fourth lesson on inequalities, and after our fourth lesson, we'll be doing a unit review where we review everything in this unit. All right, and today we're going to be reviewing compound inequalities and then going over absolute value inequalities. So let's start with our homework questions. And I see that a lot of people on this homework did pretty decent. All right, did pretty decent, but some of you still struggle with the interval notation with the union. All right, so I'm going to go over that in this problem. Okay, so first, everybody, put your answers in the chat for this homework question. Let's see what everybody collectively got for this homework question. Okay, negative 52 is greater than 13 times the quantity of 4x plus 36, or negative 6 is less than x over 2 plus x, right? So this or inequality, so pay attention to the or, and then put your answers in the chat. We'll go over them in a second. All right, so we have some answers. X is greater than negative 10. We have the negative infinity to negative 10 union, negative 4 to infinity. Same with Kaylee. And then for Elaine, negative 10 is greater than X. And then 4 is less than X. All right, so are there any more answers? If there are no more answers, then I'll start. All right. So William and Kaylee's answers are correct. So how do we do this? Remember, with or, we have to solve them separately. So let's solve this first equation first. So first, with this first equation, you have to divide by 13, right? So divide by 13, get this. Okay, then move the 36 to the other side. Going to get 4x is less than negative 40. Divide by 4 on both sides, then you get x is less than negative 10. All right. So that interval is going to be negative infinity to negative 10, and since it's not included, we use a regular parentheses on the side. For our next one, all right, we multiply everything by 2. Negative 12 is less than x plus 2x. Then 3x is greater than negative 2. X is greater, right? Greater than negative 4. All right, and this is negative 4 to infinity. Now, with or, remember that you cannot combine. You cannot combine these two equations, right? So let's say if you did combine them. If you did combine them, right? If you did combine them, you'd get negative 4x and then negative 10. This does not make sense. right? This does not make sense. Okay? Why doesn't it make sense? Because x cannot be greater than -4 and simultaneously less than -10, since -10 is less than -4, right? So this, why? It doesn't make sense, right? Because it doesn't make sense. Because it doesn't make sense, then we cannot combine this. So instead, our solution is going to be the union of these two intervals, right? The union of these two intervals, like that. All right. Are there any questions on this? Any questions? If there are no questions, then I will continue. All right. So let's solve this one. All right. So everybody, let's solve this one. Okay. I'll give you a few moments to put your answer in the chat. All right. We have some answers. Okay. So we have from Kaylee, -25 to 5 included, and then from William, -5 to 43. Okay. Let's wait some more for some other students to give their answers. So let's wait a couple more minutes for some other students, and then let's see if we get any other answers. All right. So everybody else, okay, everybody else who has not answered, please put your answer to this problem from the homework. Right. So most of you, okay, almost all of you did the homework. So just look back to your homework and paste your answer. Okay. And then we'll go over it. All right, we have a couple more answers. Okay, so we have negative 25 to 5 from Elaine, and William changed his answer. All right, very good. Unfortunately, William, that is still incorrect. Just a small mistake. The 5 needs to be included in the interval notation. All right, so Kaylee is correct. Very good job. So let's now go over it. All right, so how are we going to do this? So let's go to our slides here. So William, you made a mistake in your homework. All right, just a small silly mistake. If you did not make that mistake, your homework would be correct because you copied this problem wrong. It's supposed to be x plus 19 and you copied x minus 19. All right, so I graded your homework today, so make sure you go ahead and correct that after this class and resubmit. All right, thank you. Good job. So let's go do this problem. So let's do our first one first, since and inequalities can be combined, but not right now because these two are not equal. So at the very end, we'll combine them. So let's do them separately right now. So for our first equation, you need to multiply everything by 8, right, on both sides. Get something like this, right? Then x is less than or equal to 5, right? You move the 19 to that side. And then you have our second equation, multiply everything by 10. Okay, so you have this. Okay, then move the negative 15 to the other side. You get x is greater than negative 25. Okay, now you see that you can actually combine these now. So this one you can combine. All right. So if you actually combine these, you can see that if x is less than 5, okay, so x is less than 5 or equal to 5, then it is greater than negative 25. This does make sense because negative 25 is less than 5. So then x is just between, right? What is this? It's just between the 2 points. Okay? So now, if you look at this, you have the negative 25 to 5. Okay, actually, I forgot to graph the first one. All right, we can skip the first one. First one is pretty easy. So let's graph this one. Okay, let's graph this one. Okay, graph this one. So for this one, you have 2 points, right? And inequalities are always between 2 points. So if you see here that I saw some of you do this, right? Do this. I saw some of you do like that. And you have 2 arrows pointing here. But what is this really like, right? If x has to be, it has to be greater than negative 25, but also it has to be less than or equal to 5, then you don't need 2 arrows anymore. You don't need 2 arrows. All you're going to do is going to do this, a line right here, right? It's between these 2 points, right? So that is the graph of an inequality, right? So now let's look at our third problem, and I don't want to spend too much time on this more questions, so I'm just going to go over this real quick for you. Okay, so multiply everything by 2, right? So you get this, and since we're already combining these, you can solve them simultaneously. All right, so like that. Then you move the 9 to both sides, right? Okay, like that. All right, then you divide all 3 sides by 3. You're going to get x is less than 7 but greater than -5, and you can see that the interval is -5 to 7, and this is pretty easy. And we graph it here, it's going to look like this, right? And since it's not included, open circle and just a line right there in between. All right, so are there any questions? What do you mean you don't switch the inequality signs? Which problem do I not switch the inequality signs? Yeah, okay, so this, I can do that because, see, what is this? If you don't, well, it's still equal, right? So x, if you do this, it's going to be like that, right? I mean, no, not like that. This, right? Like that. But I know we switch it to, we just switch it to this. Same thing, right? Just swap it, right? The value is still the same. We just swap it real quick here. So the value is still the same, right? It's like swapping this into this, right? It's the same. Okay. So now let's review compound inequalities. The definition: conjunction of two individual inequalities, right? So that's a compound inequality, is conjunction of two individual inequalities, right? So some examples, right? So some examples of an and inequality, you can have x over 2 is less than 3 and also greater than 4, right? And for our or inequality, we can have x is less than -4 or x is greater than 10, right? And you can't combine those. So for this one, you can combine. And for this one, you cannot combine. So now let's go on to a little bit of solving compound inequalities. All right, so who can give me an example of, just quick example of an and inequality, then we can go over how to solve it, right? Go over how to solve it. Okay, let me just think of one. So let's say and inequality, we have 3x plus 7 is less than 4, and 3x plus 7 is greater than -10. All right, let's see how that goes. All right, so since the 3x, the x side is the same, we can actually combine these like that, right? And it's going to be greater than -10 and less than 4. So I want everybody to help me on this, right? Help me on this, okay? How are we going to do this, right? So this is just a review, so it's pretty easy. So I think everybody can unmute themselves, and if you want to participate. So hopefully everybody can participate. So who can tell me what's our first step here? So who can tell me what's our first step? Who can help me? All right, let's see. All right, William, how are we going to do this?
Can I see the problem again? We first subtract 7 from all 3 sides.
Right.
And after that, we divide all 3 sides by 3.
Okay, very good. So when you have one of these, you can divide it simultaneously, right? Divide it simultaneously. So we get x is between -17/3 and -1. Very good. Very good. Okay. So about our OR inequalities, right? We have, let's say 3x plus 7 is less than -10, or 3x plus 7 is greater than 4. All right, so how are we going to do this? All right, let's choose a different person this time. All right, so let's say Hugo. Can you help us with this? How are we going to do this?
Yeah. What's the problem?
Right. This one.
Okay, so you simplify it first.
All right, so you simplify it. Are you supposed to combine these? Can you combine this?
Yes. I mean,
Are you sure?
no, you can't. You can't. Because it's an or.
Very good. It's an or. So you're gonna have to solve these separately. All right, so let's solve them together.
Okay, so first one simplifies to 3x is smaller than -17.
Very good.
Which is x is smaller than -17 thirds. And then or 3x is smaller than -3.
Are you sure it's smaller?
No, greater, sorry, it's greater.
Very good.
Or x is greater than -1.
Okay, so
And then you denote an interval notation. Yeah, you denote an interval notation. Wait, what? What was that?
so who can tell me the numbers in this interval notation?
For the first one, it's -infinity, -17 thirds.
Yeah, very good.
And the other one is -1 infinity.
Great job. Very good. Very good. All right, so good job, Hugo. So this is how we're going to do an OR inequality. All right, so the thing is, you have to remember you can combine this one and you cannot combine the other one. Right? So just remember that when you're doing it. And also check if it makes sense, right? If you can forget which one you can combine them, and let's see if it makes sense. Right? So let's say you combine them, x is less than -10, but it's also greater than 4. Well, that doesn't make sense. So then you can't combine them, you have to solve them separately. Right. So let's go over how to graph these compound inequalities, and then next half of the class we can do some absolute value. All right, so this is quite easy. Let's just go over it real quick. So and inequalities we have between two numbers, right? Between 2 points. And or inequalities are branching out. So what does this look like? All right, so we see here and inequalities we have A and B. It's going to be like something like this. But or inequalities are branching out, right? So we have A and B here. They're branching out. All right. Very good. We also talked about interval notation, so we don't have to do this. All right, so now let's talk about absolute value inequalities. So these are just a little bit harder than compound inequalities, but we still use our knowledge of compound inequalities. So absolute value inequalities, you don't really need a definition, right? You don't really need a definition. Very simple. Basically, an inequality with an absolute sign, okay, absolute value sign, right? It's just an inequality with an absolute value sign. So some examples, right? So some examples, right? We have like absolute value of x is less than 5, or absolute value of x plus 6 is greater than or equal to 7, right? So we have all these things, okay? So now let's talk about how we solve absolute value. So the thing is, you need to understand what absolute value is. You have to understand what absolute value is. So who can tell me what absolute value is?
Distance from 0.
What was that?
Distance from 0.
Yes, the distance from 0, right? That's the distance from 0. Absolute value is the distance from 0. All right, William, were you going to say the same thing? Oh.
Yeah, but I forgot to lower my hand.
Oh, okay. So that is the geometric definition of an absolute value. So what we need today is the algebraic definition of absolute value. All right, so for this, we need a conditional statement. Conditional statement. All right, so what is the absolute value of x? The absolute value of x is equal to negative x if x is less than or equal to 0. Less than 0. Less than 0. And it is x if x is greater than or equal to 0. Right? So the absolute value of x is equal to negative x if x is negative. And the absolute value of x is equal to just x if x is positive. So what do I mean by this? So let's see. How can we give some examples of this? So some example of this, we have the absolute value of negative 6. Right, that's confusing. Right, so the absolute value of negative 6. So what is the absolute value of negative 6? So let's say negative 6 is x right now, because it's x denotes everything inside the parentheses, right? Everything inside the parentheses, or absolute value sign. So negative 6 is x, and negative 6 is less than 0, right? It's negative. So the absolute value of x, or the absolute value of negative 6, is just going to be negative x, which is negative 6, which is equal to positive 6. Right, so that is the definition of the absolute value. Now, if you just had 6 right here, 6 is positive. So that's just 6. It's just x, right? So does everybody understand this definition of absolute value? Yes? Okay, very good. Very good. Yes, I think so. Very good. Very good. Okay. So make sure you write this definition down in your book. Right? Make sure to write it down in your book, or whatever you're taking notes on. Okay, so now that we've gone over the definition of absolute value, we can start working on solving absolute value inequalities. All right, so let's look at this. Let's first look at a little example with 8. The absolute value of x is, let's say, less than 8. Okay, so let's look at this. It's negative 8 and this 8, 0. Okay, so what is x going to be? What is the solution of x here? So let's just look at equal. Let's just look at equal. If it's equal to 8, if the absolute value of x is equal to 8, then we have two possibilities. Either x can be 8 or x can be negative 8. They both equal 8. Now let's switch it back to this. Right? Absolute value of x is less than 8. All right, then what is x? All right. So if x is anything from 0 to 8, then it's going to be true, right? Not including 8. Not including 8. But also, if it's from 0 to negative 8, not including negative 8, is also true, right? So you can see this turns into a compound inequality. This turns into a compound inequality. All right? Turns into compound inequality. So now let's work on solving these. There's two cases when you're solving absolute value inequalities. Actually, there's more than one case. There's a lot of cases. There's 4 cases, actually. There's 4 cases. But let's just look at the first 2 cases here. Case 1. Absolute value of x is greater, or well, let's say less than a. What is this? If it's less than a, then you see that the number line go like this. It's 0, a, negative a. All right. So from 0 to a, not including a, well, this could also be equal, less than or equal, but let's just say less than for all. Okay, so if it's 0 to a, then this is true. But also 0 to negative a is also true. So then you get the absolute value of x is less than a. It turns into this. Case 2. Absolute value of x is greater than a. Right? It's greater than a. Then this is 0, this is a, this is negative a. From a to infinity, right? If from a to infinity, it's true. But also from negative a to negative infinity, since it turns positive, absolute value makes it positive, it's also true. So what does this turn into? This turns into or inequality. Previously, if it's less than a, then it turns into and inequality, but this time it's or inequality, right? So x is less than negative a, or x is greater than a. Case 3. Oh, assuming that with all these cases, assuming is that a is a real number that is positive, right? Assuming it is positive. Okay, these are all these cases. Case 3. Okay, case 3. Absolute value of x is less than negative a. Can anybody guess what this is? Can anybody guess what's the solution to this? Who can guess? Who can help me with this? What is our case 3 here?
I'm pretty sure it's or.
Why is it or?
because I can't see that I can combine them. Actually, maybe ditto.
It's not or, and it is not and either.
Oh, it's just the same as the one above.
No, it's not the same as one above. Otherwise, it would be okay. What is this? Does anybody else have any other ideas for case number 3? Right. It's less than negative a. The absolute value of x is less than negative a. Right. Who has any ideas on how we're going to do this? Why is it less than negative a? Can it be less than negative a? It cannot. Solution for this is no solution. Does anybody know why it's no solution?
Get it now because x is to be positive, but positive number can't be a negative number.
Exactly. Because absolute value makes everything a positive number. And positive numbers cannot be less than a negative number. Right? No, absolute value of x. Right. Right? It has to be positive. Right? So it cannot be less than a negative number. It cannot be less than 0. Okay. So now let's look at this. Our case 4. Absolute value of x is greater than negative a. What does this equal? Right, similar to case 3. What does this equal? Can anybody help me? So let's see who's here. Kaylee, do you have any ideas on how we're gonna do this? Kaylee, can you help us with this?
I think maybe it's also there is no solution.
Why is there also no solution?
Cause the absolute value has to be positive.
It is positive, and it is greater than a negative number, which is possible.
I think it could be any number.
Exactly. Very good, very good. So this is all real solutions. Everything, every number you plug it in. This is always true. Everything, all real solutions. Why? Because the absolute value of x is always positive. It's always positive, right? Always greater than a negative number, right? It's always positive. So the absolute value of x, it always has to be greater than a negative number, right? Take any number out there, negative infinity, right? Negative 3, let's say, negative 3. The absolute value of negative 3 is always going to be greater than negative a, no matter what negative number it is, because it has to be positive, right? It is always positive. That's why it's all real solutions. On the other hand, number case 3 is no solution because the absolute value of x has to be positive. It cannot be negative. So these are opposite cases, right? So 3 and 4 are odd cases. These are odd cases, right? You won't see them very often, but they are there. Right? So I want you to make sure that when you do come around a problem with no solution or all real solutions, you know how to deal with it, right? But mostly we're going to be dealing with 1 and 2, case 1 and 2. But I'm going to include one problem with case 3 or case 4 on the homework, right? So make sure you know how to do these, right? All right, so I see some comments here. All right. Yes, so the interval notation of case 4 is negative infinity to infinity. All real solutions. Yes. And you cannot graph it. You cannot graph it. Because negative infinity cannot be a point, nor an infinity. So you can't graph it. So for if, all right, for cases 3 and 4, you cannot graph. All right. Yeah.
So for case 4, could we just put negative infinity and infinity on the number line and then put the open circles?
No, because negative infinity and infinity cannot be points, right? You do not know what they are. They're intangible, right? They're too big. So they cannot be points. You cannot graph. Right? That's why they're not included in the implementation and you cannot graph them. Right? Because it's infinity, right? You can't, you always can't really do anything with it because it's infinity, right? So now let's look at the graphs of absolute inequalities. So case 1, for case 1, it's going to be looking like this, right? Because it turns into an inequality. For case 2, it's going to look something like this because it turns into or inequality. For 3 and 4, you have no graph. All right. So now let's go over our practice problems. All right. So let's see our practice problems now. Okay. So I'll give everybody a moment to do this. All right. So our practice problems. So everybody do this real quick, and then I'll come back shortly. All right. Let's see what we have. So the absolute value of x is greater than or equal to 38. All right. And then greater than or equal to negative 844. Probably not. It isn't, right? So we need to find what x is, not just what absolute value of x is. So we need to find what x is, not just the absolute value of x, right? So what x, right? Unravel the absolute value, right? Find what it turns into. What does it turn into, right? Okay, we have William here. Negative 2/19 to 2/19. All right. Okay. Very good. Although it is not the correct answer. Okay, so let's see what it is here. So very close though. At least she unraveled the absolute value. So that's very good already. So let's move the 47 to the other side. Okay. This. Then multiply everything by 19. Get this. Right. Now, what can anybody tell me which case this is? Is this case 1, case 2, case 3, or case 4? Which case is this? Right, so which case is this? Right? Let's see. This is case 2. Very good. Case 2. Great job. Great. This is case 2. So what does this turn into? This turns into an OR inequality. This turns into OR inequality. So the tip is if the absolute value of x is greater than or equal to or just greater than something, then it turns into great OR inequality. If the absolute value of x is less than something or less than or equal to something, then it turns into an AND inequality. So let's look at this. It's going to turn into x is greater than or equal to 38, or x is less than or equal to negative 38. All right. That's what it's going to turn into. Okay. So now let's look at this. It's going to be negative infinity to 38 to negative 38 union 38 to infinity. That's what it's going to be. Okay, let's go on to number 2. Okay, so let's think about what case this is. All right, let's look at our answers. Okay, so we have x is greater than 3. We have negative 13 to negative infinity, and then 13 to infinity. If x is greater than 17, okay. And Ethan has the same answer as Isabella, very good. And William has the same answer. Oh, you forgot a negative sign there, William. The negative infinity to negative 13. But I'm pretty sure you got the correct answer. All right, so let's look at this. Let's look at this. Okay, so if you look at this problem here, you can see that clearly the x, the absolute value of x minus 2 is greater than something. Is greater than 15, actually. Okay, it's greater than 15. Okay, so this is going to fall under case 2 again, because whenever your absolute value of x is greater than something, it's going to turn into OR inequality. So we're going to have, it's going to split into 2 cases. X minus 2 is going to be less than negative 15, and x minus 2 is going to be greater than 15. Okay? And then you're going to have x is going to be less than negative 13, and or x is going to be greater than 17. Okay, so it's not 13 anymore. It's not 13 anymore. And so what did we get here? So it's not 13 anymore. Okay, so it's going to be 17. This is compound inequality. All right, so you're going to get negative infinity to negative 13 union 17 to infinity. So if you made a mistake, do get your mistake now. All right, make sure you pay attention to the signs here. Okay, so we're running out of time, so let me just do the last one. So the last one, you want to save the absolute value inequality until the last moment. Okay, so move everything to the other side first. All right, then it'd be like this. And so when you divide by negative, what happens when you divide by negative? You switch the sign. Okay? So now we're going to have like this. This is going to be AND inequality, because it's case 1, because the absolute value of x minus 5 is less than 1. So it's going to be AND inequality. So now let's look at this. It's going to be x is less than 6, greater than 4. Okay, so 4 to 6. Okay, so now let's graph them. So if you graph them from the first one, it's going to be, first one was case 2, so it's going to be branching out, right? It's going to be branching out like that. You see our second one, also case 2. It's going to be branching out. Think goes like that? Yeah, okay, not included. So open circles. Then our last one was 4 to 6. All right, so, but this one is case 1. Right? It's case 1. It's going to be in between 2 points. So 4 and 6 here. Very good. So thank you for listening, everybody. And that's the end of our class today. And so this one, absolute value inequalities are pretty hard to understand well. Okay, on your first time learning them. So of course we'll have that unit review next time and talk more about it.
Bye bye.
All right. Thank you. Bye, everyone.
Bye. Thank you.
Bye.